Good morning, everybody, and welcome to the Compute Leadership session covering EC2. It's great to have you all here. It's really been quite a great start to reInvent. Hopefully, most of you, if you weren't able to make Andy's leadership session or Andy's keynote in person, hopefully you watched it live and just saw the number of exciting launches that came out. I've spoken to a few people today and said they're already struggling to keep up with everything we've launched. And so exciting to do this every single year. I'm Dave Brown. I've been with AWS now for 12 years. I actually started off as an engineer on the EC2 team back in Cape Town, South Africa. There's about 14 of us on the team when I joined in 2007. Today, I lead all of compute and networking for the EC2 service teams. And so it's been an incredible journey and a really fun to be part of. We like showing this slide every year. It shows just the number of customers that we're using, that are using AWS. Many of them, you might see your logo up there as well. We love working with customers. We love getting feedback. And one of the things that really stands out is just the breadth of the customer base that's using EC2 today. Everything from startups, companies like Pinterest, Lyft, Zynga, Redfin, Uyala, started their business, in many cases, on AWS and have grown into large companies today. In the enterprise space, we have companies like Netflix, who not so long ago was a startup themselves. Companies like Verizon and Intuit, running very, very large applications where security is absolutely critical in many of those cases. We also have a number of public sector companies supporting many governments around the world, running on EC2 and AWS. And then in the SI and ISV space, helping organizations to bring their applications to AWS, many SIs, such as Genesys and SecondWatch, helping customers move to the cloud. Every year, Gartner runs what's called the Magic Quadrant. The Magic Quadrant for cloud providers is actually one of the longest running Magic Quadrants, and it's been around for 9 years. And every year, AWS has won that Magic Quadrant. As you can see, this is the one from this year, and we continue to be a leader in both ability to execute and a vision, which are the two axes. One of the things that's really stood out in that quadrant is, and kept us in our leadership space while other providers have actually moved around, is the availability that we've been able to achieve on AWS. We really think about availability differently as a cloud provider. We have some fundamental designs in our architecture and platform that really sets us apart. And so the next largest cloud provider actually had 7 times more downtime hours than AWS in 2018. And one of the things that Andy Jassy likes to say is there's no compression algorithm for experience. It's really it's a great statement, but it's very, very true. And for us, that experience has been learning how to operate at scale and run at scale and keep the cloud being highly available and learning from our lessons and diving deep. And so what we want to talk about today is a compute platform for every workload. When we started AWS back in the day, we literally had one instance type. We didn't even bother giving it a name. It was just the instance. And there were very few workloads we could have hosted on that instance, but the cloud continued to grow. And over the years, we continue to iterate at what new workloads do customers want to bring to AWS. And so as we dive into this presentation today, we want to look at a few things that really help us support virtually every single workload. First of those being performance, security, and innovation. We can look at the breadth and the depth of the platform, and some of the abstractions to help you manage your cost and your complexity in a better way. And then some enterprise applications that have some unique capabilities that are running on us today. And then obviously a big talking point for this year's reInvent is how are we bringing the cloud closer to you? And so let's dive in. World-class performance, security, and innovation. And I want to go all the way back to what the original EC2 server looked like. And when we set about building EC2, we took the simplest path. The first thing you want to do is you want to find a hypervisor. You probably don't want to build your own hypervisor to start with, and so we took Xen, and we used Xen. We built a lot of infrastructure around Xen, and allowing Xen to customers to launch and manage instances on top of Xen. This is a diagram that kind of shows what that looked like. And so right at the top, you've got your customer instance, and that's where your instance runs on Xen. That's called the DOM-U. Underneath that, you've got Xen as the hypervisor, which is running on the same physical machine and using the same Intel cores as the customer instance. And so there's literally only a single processor available to that box. And then what you do is you integrate networking and storage and management and security and monitoring all into that Xen environment. But the important thing is there's a single core, single Intel processor back then. Some challenges with this model. The first was innovation. We really didn't feel like we could innovate at a pace that was necessary to grow the business, and customer demand was exceeding what we were able to deliver. Second was performance. While performance wasn't bad, some of the tail latencies were challenging. And so on the networking side, we would see periods of jitter. And on the compute side, you'd get periods on the storage side, sometimes where your IOPS weren't as what they needed to be. The third thing was patching. patching the hypervisor was incredibly challenging. If you have a security vulnerability that needs to be fixed, or you have a critical patch that needs to go out, you don't want to have to interrupt a customer workload. And that was something we had to do back then. And then efficiency. Because everything runs on the same core, we lost about 20% of the utilization of that CPU just to the management side of EC2. And so we knew things had to change. What changed was AWS Nitro. In 2012, we started the migration to AWS Nitro. We brought in a second card that went into the machine. It was an offload card that we actually put networking onto. And so what that diagram looks like now is customer instances on the hypervisor are using the CPU within the server, but everything else on that machine is actually running on a separate card that we put into the box. Today, those cards are made by Annapurna, and all of our networking, storage, monitoring, management, security, all run on those cards. There is 0% of that CPU in that machine that's used by AWS to manage your instance. You get 100% of that core. That's allowed us to actually go as far as providing you with what we call our bare metal instance, which is where you can actually run a machine without a hypervisor and get a true bare metal experience on AWS. I want to take a look at a few of the things that Nitro's brought to EC2. The first of them is performance. Performance has changed in a big way with Nitro. And one of the ways that this stood out for me was back in early 2018 when I was in a meeting with a customer, and it was a customer that was looking to bring an application to EC2 that needed to sample satellite data. And with satellite data, you're essentially sampling the air. You've got a big dish, and every couple of milliseconds you wake up and you want to see what data that dish has received, and then you want to take action on that. And the critical thing about this is it's really a real-time application workload. You've got to wake up every 4 milliseconds, but with less than 150 microseconds of jitter. And they were really, really struggling. And on the next graph, you can see the top line was what they were seeing. They were running on a C4, which is a pre-Nitro instance, and they weren't able to achieve that 150 microseconds or less of jitter. And in the meeting with me, they were literally saying, Dave, we're not able to achieve this on C4. Is there any way you guys can help? And we'd launched C5, which was our first Nitro instance, literally 3 months before that. And I'm sitting with the customer, and I said, well, did you try the C5, which is our new Nitro platform? And they were actually able to rerun their test in that meeting. And about 10 minutes later, we had the blue line, which showed that they were able to achieve that level of efficiency and enough little jitter that they were able to achieve their workload of maintaining less than 150 microseconds of jitter. The yellow line, we actually went and rerun the test on our bare metal machine when we removed the hypervisor completely. And what was super interesting there is the gap between the blue line and the yellow line, which shows you how little overhead the Nitro hypervisor adds. And so really just astounding on the compute front. The other side is storage. Storage latencies, both at the P50 and the tail of the P99, have improved considerably. What's amazing to look at here is the i3 instance is considered to be one of our premium storage solutions, and it is really, really good. And it provides 0.08 milliseconds of latency for IOPS. But look at the Nitro instances. All of them, including R5D and M5D, which is just local disks, it's not a storage service, are giving you latencies that are significantly better than that. And our new i3EN with latencies as low as 0.02 milliseconds. On the networking side, we see it as well. The blue here indicates the C5 18XL, which is a Nitro-based instance, but not using the very latest Nitro networking card. And then our C5N 18XL is using our very latest Annapurna networking card, which is capable of providing you with 100 gigabits of networking. And it's just astounding to see on throughput how we're able to do 100 gigabits, stay in throughput there at 90. Latency, lower on that is better, by the way, so 27 microseconds of latency. And at the packets per second, able to achieve just over 5 million packets per second, which is critical for networking workloads. This is actually an external survey that was done, so these numbers aren't from AWS. And they actually ran it against a couple of other providers as well. And what's really interesting here is to see how we compare. And so throughput, you can see AWS is nearly 3 to 4 times better than the other competitors they compared against. They don't say who they were. Latency, you can see 27 versus 34 and 43. And then packets per second, significant lead, 5 million versus 1.5 million. On the security side, number of things we changed. Firstly, encryption. Every single component and all communication within Nitro is encrypted. There's nothing in the system that doesn't make use of encryption. Second part, and this is an area that's becoming more and more important, is secure boot. When a server boots up within EC2, we hold that server, we suspend the server and validate every single component, every single piece of firmware to guarantee that everything is as it should be before we allow it to boot up. Third is patching. We're able to do live updates of every single component in the system. And so while we do use things like live migration, we're able to patch a hypervisor, patch a kernel, patch any part of the operating system right underneath your instance without having any impact on the running workload. And fourth, and most importantly, is there's literally no shell access to Nitro. We never built a shell. We never will build a shell. We never want any engineers, nobody within AWS to be able to log into a server. And that's one way of guaranteeing that your data and your workloads are truly secure and private. And so with all that great security, one of the things we thought about is, well, how can we help customers solve some of their security challenges? Now, how many of you have ever tried to store some secure data or sensitive data on any computer, whether it's an EC2 instance or a computer within your own data center? And the problem always becomes, well, where do you put the key? And then how do I make sure this is really protected against somebody that has the key or has access to that server or shell access? And very often it comes down to a very small group of people, or you have to use a different service that isolate an instance, but then you don't have access to it. And so it's a really hard problem to solve. And so we put our heads together, and today we're happy to announce the availability of AWS Nitro enclaves, which is available in private preview, and so you're able to sign up for that, and will be generally available sometime early next year. And what Nitro enclaves provides you with is a completely isolated and secure compute environment. It has no storage, no ability to log into the instance, no network connectivity, but it has its own secure channel between the instance and the enclave itself. It's also supported across all of our latest instance types. And so let's take a look at how it works. What you do is you pick any instance. In this case, we chose the M5 4x large. And you allocate some of that, the core and the memory to the instance, and you allocate some cores and memory to the enclave. In this case, we gave 14 vCPUs to the instance and 2 to the enclave, and 48 gigs of memory to the instance and 16 to the enclave. And now I'm able to actually take any Docker container or any container image and run that in the enclave, and store my secrets in that enclave, and access that through the vSOC secure channel from the parent instance. Also, this is using AWS technology. This is not using any other proprietary technology from CPU manufacturers. This will work across all of our CPUs and all of our instance types. And we're excited to have this out there, and think it's going to make a real big difference. And finally, on innovation. This is one of the areas that Nitro's had the largest impact. See if you can work out where we launched Nitro. And it was 2017 was our first Nitro instance that came out. And so we've nearly had a 4x increase in instances from 2017 to today, more than 270 plus instances. You can see that in terms of categories, everything from general purpose to burst, to the more advanced dense storage, GPUs, graphics. There's just new instances coming out all the time. And capabilities, choice of processors, faster CPUs, high memory, instance storage, and a whole lot of options that go with this make up more than 270 different instance types for you to choose. And so let's take a look at the depth and platform choice. And the way I want to start with this is looking at processors. And today we support 3 processors across the platform: Intel, AMD, and then our AWS Graviton processor. And so start with Intel. Where Intel really starts is the compute-optimized instances. And so these are C5s and C5Ds and C5Ns, high-performance compute. And what you really these are focused for applications that want to run compute-intensive workloads and giving you the very fastest CPU. This is not just standard Intel Skylake and Cascade Lake, by the way. We actually work very closely with Intel to make sure that we can provide you the very best core frequency and sustained turbo support so that you get the absolute fastest processor for cloud processing. On the networking side, we offer up to 100 gigabits, and we also have Elastic Fabric adapter that can take you down to 15 microseconds of latency. This was just an incredible use case. This happened a few months ago. There was a blog post that came out from Descartes Labs, where they had used C5 instances and managed to run 40,000 cores for a high-performance computing workload. And so they set this cluster up, and what they were trying to do was to see how high they could get up in the top 500 supercomputing list. And they actually achieved the 179th place. It's kind of amazing, but what really makes this incredible is kind of what they wrote. They basically said, we didn't ask Amazon to give our engineers anything special, no special dispensation, discount, or anything. They didn't even tell us they were going to do it. They just used a company credit card and spent $5,000. And so I'm assuming pretty much most of us could achieve somewhere in the top 200 of the top 500 supercomputing list just with our credit card and running a few instances on EC2. That's where we are. It's pretty amazing. Another really good one is Fred Hutch. What they use in the C5N instance types and running very, very large clusters. And what they've been doing is working on how do they improve some of the cancer research, eradicate cancer, and developing therapeutics to fight cancer. And so they've been analyzing 10,000 biological samples, and they were able to decrease the time from 7 years to 7 days. When I actually read this case study, I actually went to the marketing team and asked them if it was correct. I actually said, this has got to be days to hours, not years to days. And it literally is years to days. And you think about the impact that that's having on something as critical as cancer. We also recently received a number of awards from HPC Wire. They give awards out all the time, as well as the one for the best HPC cloud platform. And so it's an important space for us. The other one is we have some instances that just sort of push the envelope on a whole lot of things. First of those is the high frequency, which is a 4 gigahertz sustained core frequency CPU. We put this out for some very specific use cases, one of them being EDA, which is companies that actually manufacture hardware and chips. They need to run their simulations at very high frequencies. It turns out that customers have been very creative with these and found a number of different ways to use them, including getting the absolute most out of a license when the licensing system says per core. And so if you want the most out of a license, run at 4 gigahertz. A lot of customers are doing that. And then high memory. Many of us can remember a day where the operating system we used only supported 640K of memory, right? And you had to do a whole lot of stuff to get around that. These machines have up to 24 terabytes of RAM. When you turn the machine on, it takes a while just to load the memory. And obviously available at AWS as virtualized instances, as bare metal machines, but you're able to launch that within seconds and use those. And so very popular with very large in-memory databases and SAP HANA workloads today. And so on the Intel side, we've achieved a lot. It's been 14 years of great partnership with AWS, and we've launched over 200 instances together. I want to go and take a look at AMD. We launched AMD last year at reInvent. It was the first time we brought AMD to AWS. And again, just seen really, really strong adoption. And so today we have the M5A, R5A, and T3. And so that's general purpose, memory optimized, and burstable. The one that's missing there is our compute optimized instance. The big benefit of AMD is you get 10% cost saving on compute and memory. And it's seamless application migration. Because AMD supports the x86 chipset, you can take any application that runs on your Intel processor today and just relaunch by changing the instance type in the console. And so it's that simple. And so you get an immediate 10% cost savings. And that's what Expedia did. So Expedia had a number of microservices where they had a look and said, well, these are the ones that actually aren't utilizing the CPU as much as we would expect. And so they were able to migrate those to AMD and immediately get a 10% cost saving by doing that. And I'm also happy to announce the availability of the AMD-based compute-optimized instance, which will be available in the next few weeks. And so AMD's recently brought out the new EPYC. It's the second-generation EPYC processor called Rome, which takes a significant step forward in compute performance. And so we're launching the C5A, which will be an AMD-based processor. There'll be 8 instance types with up to 192 vCPUs, 384 gigs of memory, 7.6 terabytes of local NVMe storage, as well as 100 gigabit networking support. And so this is perfect for any applications that require a lot of CPU intensive, that you'd like to get a 10% cost saving on. AMD is a great option to go and look at there. And finally, we want to dig into and have a look at our AWS Graviton processor. We launched our first Graviton processor back at reInvent last year. But the story actually starts a long time before that. If we go all the way back, as I said earlier, to 2012, 2013, we started to work with a company called Annapurna Labs out of Israel. And we were building Nitro components at the time and using them for our offload cards. And what we found was they were incredibly smart, firstly, and secondly, their culture was just very similar to the culture that we have in AWS. And so in 2014, we decided to buy Annapurna Labs. And one of the tasks we gave them was to see if they could develop the next generation of processors. Obviously, other processor manufacturers continue to iterate, but we really knew if we were going to push the envelope on price performance, so for what you pay, how much performance do you get, and a number of other critical factors, we need to look at making our own processor. And so at reInvent last year, we announced the A1 instance. One of the very first cloud providers to provide an ARM instance in the cloud, and built on 64-bit ARM Neoverse cores, which is AWS designed silicon at 16 nanometer using that manufacturing technology. And so it had 16 vCPUs, 10 gigs of memory, and 3.5 gigs of EBS storage. 10 gigs of enhanced networking. The really important thing was it's 45% cheaper than the alternative for scale-out workloads. And so if you had a workload that you were able to recompile, or it was interpreted so you could run it on ARM, significant savings. And so what it did, there was some debate internally, honestly, as to how successful it would be and who would be using it, but it really ignited the ecosystem. ARM traditionally has been in the mobile space and some limited server space, but it really you started to see more and more operating systems supporting ARM, and you can see we've got a significant number there. We started to see container services supporting ARM as well, and Amazon ECS is available today with full ARM support, and EKS is in public preview currently. And then we've also seen a number of AWS services integrate with our ARM processor, including Marketplace, Systems Manager, CloudWatch, AWS Cloud9, things that need to run on the ARM processor itself. And so it's really taken off. Adoption has exceeded our expectations. Nielsen is a great example, the company that does the television ratings. They used ARM for 12 billion batch jobs that they run every single day. And so they were able to migrate those to ARM and get a significant saving, potentially up to 45% for those workloads. So we thought, could we do more? And now, what we didn't tell you at reInvent last year was the ARM processor that we launched was actually the one we've been using in Nitro for some time. And so we put that together and delivered an A1 instance. For the last couple of years, though, Annapurna Labs have been working on the real ARM processor that we wanted to bring to the cloud. And that's what we announced today, which is the availability of the M6, R6, and C6G instances using the new Graviton 2 AWS processor. Now, this is a completely new generation of ARM-based instances powered by Graviton 2 that offers 40% better price performance than the current x86-based instances. So this is a M6. It's the 6th generation, the only instance type that has a 6th generation, and it's providing 40% better price performance than the current 5th generation instances. M6G is available today in preview. You can go and try it. The others will be available within early next year. Similar to the previous ones, built on 64-bit ARM Neoverse cores, instead of using 16 nanometer, it's now using 7 nanometer for its manufacturing process, a significant step forward. Up to 64 vCPUs, 25 gigs of networking, 18 gigs of EBS throughput, and 40% price performance advantage over the current x86. So just how good are these new Graviton EC2 processors? So once we got the first one back from the labs, they started to come in. A couple of months ago, we started to run some benchmarks, and they surprised us as well. Here are the benchmarks. So we took a couple of the standard ones. So SpecInt 2017. You can see there the blue line shows you what you'd get from an x86, current 5th generation x86, so we assume that's 100%. The Graviton 2 M6G gives you 144% improvement on the current x86, so 100 versus 144. The Spec JVM 2008 came in at 143%. Nginx, a standard web load balancing application, achieved about 123% better. And Memcached, 142. And so these are standard workloads that you're running on. Now you can bring them to ARM and get significant improvement over what x86 has been giving you. So we're super excited about where this is and what we've been able to achieve here. Again, the challenge of moving to ARM is obviously moving your application stack to ARM. We got a significant number of services that can help out there. But the real benefit is 40% price performance advantage over those x86 5th generation and significantly better performance in many cases. So we're excited about what we've done there. So that's the processor space. Also on the accelerator side, so if we look at accelerators, we've done a number of interesting things there as well. The first is NVIDIA. So NVIDIA we've been working with for many, many years. We've had their GPUs on AWS for some time. These are two of the current ones. And so really in the machine learning and HPC space, we have the P3 and the P3DN instance. And so on the machine learning side, you've already got two sides to machine learning, training and inference. And so the P3 is the one that you want to use for training. Fastest GPU, instance training available within the cloud today. And then we recently launched our G4, and that's targeted at inference and graphics. And so if you have graphics workloads, desktops, 3D design, that sort of thing, the G4 is what you want to use, and then machine learning inference as well. And it's cost effective, two of the best. And Pinterest are actually using this. Pinterest uses the P3 to accelerate deep learning models, which enables them to fast and unique discovery experience for its 300+ million users. So when you're searching on Pinterest, there's a lot of deep learning that they've run behind the scenes to make sure that they're giving you the very best search results based on your past usage. One of the things we wanted to go after next, just like we had the Graviton processor, we said, well, if you look at the cost of doing machine learning very little of that cost actually goes into the training. Training is only about 10% of the cost of running machine learning. The real cost with machine learning is inference. And so we figured if we can make a real dent in the cost of inference, well, we can make a significant impact to the cost of machine learning overall. And so at re:Invent, we're happy to introduce the Inf1 EC2 instance, which makes use of the new Inferentia processor accelerator from Annapurna Labs. Provides increased throughput, so up to 3x higher the throughput compared to a G4 instance, and up to 2,000 tera operations per second. So a significant step forward on throughput. About 40% cheaper than running the same inference on G4. And so that 90% of that circle is now 40% cheaper for running machine workloads. And then from a framework point of view, obviously we need to make sure all the latest frameworks are supported. And so we support the most popular machine learning frameworks, including TensorFlow, PyTorch, and MXNet. And so excited about what's happened here as well. And so let's take a look at some of the abstractions around cost and complexity. So this is one thing we've been struggling with. Too much choice can add complexity. And so I showed you guys a slide earlier, and I was like, look at this. We've got 270 different instance types. And I'm sure some of you were thinking, great, but which one should I choose for my workload? And this has become a challenge. It's almost like, well, AWS in many cases provides me with too much choice. And we wanted to go and tackle that. And so happy to announce, launched actually at Midnight Madness this week, is EC2 Instance Discovery. And this is a simplified way of finding the correct instance for your workload before you launch it. And so it's a single sort of source of truth for all the latest instance types, providing you with details about the attributes, the best use cases, regional, which regions it's in, what zonal offerings we have, and pricing. You're also able to compare the hardware attributes and the pricing between various instance types. And then also it's programmatic access. Until now, it's been a lot of documentation that you've had to go through. And now it's a single source tool that you can actually integrate your application and your image instance selection with. But what about optimizing instances for already running instances? So what happens if you're running a fleet today? Could we take a look at what you're doing and understand if there might be a better machine for you to actually go and utilize? And so we're happy to announce AWS Compute Optimizer. It delivers instance type and autoscaling group recommendations for instances that are currently running. And so it applies insights from millions of workloads to make recommendations. So given our scale, we're able to look at what customers are doing across a very, very broad spectrum of workloads, run machine learning against those, and make a better recommendation on what you might want to consider for your instance type. And so it saves you time comparing and selecting optimal compute resources for your workload. We'll do that for you. It recommends 3 optimal instance options for EC2 and EC2 autoscaling groups from over 140 instances for our MC, RT, and X families. And it's also available at no additional charge. So you can go and start using that immediately at no charge. And so what does it do? So basically, you've got to go and sign up in the console and indicate that you would like it to analyze your workload. And it takes about 14 hours. It does analysis, collects CloudWatch data. It needs some history. And then it'll begin making recommendations. So it identifies the workload characteristics and the profile based on the data that it's gathered. It goes and runs a whole lot of models to compare that to other data that we have. And we ultimately make the best recommendation in terms of which EC2 instance type and which autoscaling groups or configuration of autoscaling groups you should use. It also helps you sort of visualize a what-ifs analysis based on the impact of potentially moving to a different instance type. So very, very powerful tool. AMI or AMI. So whether it's AMI or AMI, we need an easier way to build images. For those of you that don't know that, there's a lot of debate at the moment as to whether you pronounce that word AMI or AMI. It's AMI, by the way. And so happy to announce EC2 Image Builder, which is a complete, simplifies the creation, maintenance, validation, sharing, and deployment of Linux and Windows Server images. And so until now, what customers have been doing is either using several open source frameworks, managing this themselves, writing various scripts, and in many cases, it becomes a pretty painful thing to manage. And so now, completely managed through EC2 Image Builder. And so you basically start with your source image. You can prepare that image in whatever way you like. You customize the software, the configurations. We provide you with a whole lot of templates and tools to make sure that that image is actually secured. Some of the basics, making sure you're not leaving keys on that instance. We provide you with a whole test suite that allows you to test that image and make sure it's going to be correct. And then we'll take care of the bundling of that and distributing that image to any regions where you would like it to be available on which accounts. And so a full suite of management for building and managing images, or AMIs, within EC2. Finally, we're always looking for ways to reduce the cost for customers, right? And this is just ongoing. Regardless, we often speak about this internally. What are the ways we reduce the cost? And then we want to be cost following and pass those savings back onto our customers. Today, we have a number of different ways of you to consume EC2, right? We have on-demand, which is recommended for your spiky workloads, or workloads where you don't yet understand what the compute workload actually looks like, or what the performance is going to be. We have reserved instances, where you have a good idea of what that workload looks like and how much you're going to need. You want to buy a reserved instance. And then we have spot instances as well, which is really giving you the opportunity to bid on spare EC2 capacity. And so this is sort of if you have a fault-tolerant workload, a workload that doesn't mind being interrupted. It's flexible, normally stateless, because what happens with spot is if we'll give you a machine for a period of time, and if we decide we want it back, we can take it back, and your workload will stop running. But those are three of the ways that you can consume EC2 today, and they've been great. There were sort of two challenges, and we've heard this feedback from customers. The first one was they needed an easy way to manage these commitments, specifically on the RI side of the house, for EC2. And so it just became too complicated. I spoke to many customers that had engineers or teams that were trying to work out how many RIs to buy for which instance types that was going to give them the best savings on EC2. So it became too challenging. The second one is customers were looking for improved flexibility. Customers change instance types. Sometimes you'll start on instance 1, you'll run for a period of time before you decide you want to move to another instance. We've now just launched a tool that makes recommendations. You want to be able to take advantage of those recommendations. You don't want those things to go and affect the fact that you bought a reserved instance for a specific instance type. And now you'd have to go buy another reserved instance and have to give up the old one. And so a couple of weeks back, we introduced AWS Savings Plan, which provides you with the same great savings that you have for reserved instances, but with the flexibility that you've been looking for. And so it's super simple, easy to use. We actually make recommendations through Cost Explorer. You essentially go in and tell us how much you would like to commit to spending per hour, and any usage that you consume across the various instance types that's within that, you get the great savings of up to 72%, the same as you get for RIs. It doesn't have any of the requirements that RIs had, where you need to provide us with instance family, size, operating system tenancy, which region you're in. There's ways with Savings Plan to kind of ignore a lot of that and just make the commitment to spend a certain amount. And then you're able to launch different instance types and still get the great savings that you get with RIs. And so launched this about 4 weeks ago. We've seen really good adoption so far, and so excited to see where that goes. And so you want to make sure, as you think about your cost model on EC2, that you're using the right instance, the right type of saving for the right workload. And so at the bottom over there, we've got your workloads that are sort of, you understand them really well, they're steady state. That's where you want to look at Savings Plan and reserved instances. The middle workload is the ones where maybe it's a new workload, or it's a workload that's very, very spiky. Maybe you've got the sort of daily spike that's happening in your workload. There you want to look at on-demand. As those workloads become stable, you'll move them down to Savings Plan and reserved instances. And then finally, for some of those workloads right on the top, maybe run once a day, they're very fault tolerant. They don't mind being interrupted. That's where you'd like to look at Spot. And we also have a number of AWS services that also help you to make things more efficient. Things like auto-scaling, scaling up your fleet. EC2 Fleet, which allows you to automatically choose the best one of these pricing options and launch the correct instance based on the workloads you're running. I want to look at a few enterprise workloads, starting with Windows. So AWS is the best cloud provider for Windows. We've got the most capabilities. We have 48 more capabilities than on another cloud provider. 2 times the regions, multiple availability zones. From a performance point of view, 2 to 3 times the performance that we're seeing. And the other thing is we launched Windows back in 2008 on the cloud. And so we've been helping customers to migrate to AWS with Windows for the last 11 plus years. So a significant focus on Windows. We have teams focusing on it, and many, many customers using Windows on AWS. What we are seeing, though, is some vendors are applying some license pressure to lock our customers in to not migrating to AWS. And so, when maybe, at first, when there's a concern from an organization, one of the things you'll see them do is change their license requirements, where they say, this license you can use on-prem, your existing license you can use on-prem, but you're not allowed to go and run this on another hyperscaler. And so what that means, the problem with that is it takes the choice away, right? You as a customer, you're no longer able to make what might be the best decision for your workload because you're basically locked in because of a license decision that another company's forced on you. And that said, though, we're making it simpler to bring your licenses to AWS, and this is a big area of focus for us. So introducing simplified Windows and SQL Server bring your own license to AWS. This is a new host-managed capabilities to support existing licenses. So if you have licenses today and you want to bring them to AWS, one of the requirements is you have to make use of dedicated hosts. Running on dedicated hosts, while it solves the licensing problem, has been a little challenging in managing those hosts, understanding where your licenses are allocated to which hosts, because you have to control that allocation. And so with the simplified Windows and SQL Server license program or service, we're giving you much more flexibility. So now dedicated hosts allow you to use your existing, whether it's per socket, per core, per VM, software licenses. You can bring those and run them on AWS. A reduced management. Because it's integrated with another service called AWS License Manager, we're helping you where to place those licenses and how best to make use of them within your environment on AWS and providing recommendations. And then most importantly is better visibility. So it's giving you improved visibility into the utilization, so especially around the core utilization of the dedicated hosts, and helping you to manage the per socket and per core software licensing. What this really does is it gets you closer to being able to treat dedicated hosts and launching instances, whether it's Windows or SQL Server, in the same way as you'd launch any other instance, with trying to have an impact from a licensing decision be as small as possible. We also have another program, AWS End of Support Migration Program for Windows. So obviously, as Windows Server is some parts that are being phased out, we have a whole program that we've put in place and announced that's helping you. If you have a workload today that's making use of Windows Server, you're able to bring that to AWS, and we'll help you with the migration. In many cases, for many customers, and these are some of the customers here, that migration has been what we call a modernization program, which is actually migrating away from Windows to another operating system, in many cases, obviously Linux, as the chosen operating system. And these are just a few of the customers that have actually done that. One of the great things is if you can get away from the license restrictions that are put on you, the cloud just becomes so much more dynamic. There's so many more opportunities. You're able to run order scanning groups without having to think about the fact how many licenses do you have per machine. It really, really holds you back. And so the modernization program, if you're interested in doing that migration, you would like some help, go and have a look at that program that's available there. The other big one for us, and this is a workload we've had for some time, but it's really, really started to take off, is SAP. Customers running SAP. We spoke about those high memory instances earlier. The most common use case for high memory is actually SAP. SAP HANA is an in-memory database, and we have customers that are literally running up to 18 and 24 terabytes of memory. It literally scales vertically, and so many of those customers are just waiting for the next instance type to come out so that they make sure that they've got enough headroom for their database. But it's been many, many years of innovation between ourselves and SAP. We partnered together and actually launched the very first 2 and 4 terabytes instance types in the cloud of terabytes of memory. This was a couple of years ago, our X instances. And just a few weeks back at the SAP conference in Barcelona, we announced the 18 and 24 terabyte instances. SAP's been a great partner, and you can see the different size that you're able to select there, based all the way from an R4, R5, all the way up to 24 terabytes of memory for scale up and then scale out as well. So we have full support across the SAP HANA stack to allow you to scale out to 48 and all the way up to 100 terabytes for some of their larger OLAP databases. So it's, one of the customers that we've partnered with is Lamborghini. And Lamborghini is one of many customers that have migrated their SAP workload from their on-prem location to AWS. And they were actually able to reduce their costs by 50% when they did that. And that's a pretty common statistic, by the way, is when you see customers migrate their SAP workloads to AWS, very often the cost savings are somewhere around the 40 to 60% range. Just a significant impact. And then it also comes with significantly more performance. And so up to 250% burst for their visitors. The other thing it does is it allows your SAP developers to make use of all the other systems within AWS, all the other services. And so we're starting to see SAP developers do things like integrate with Alexa and Amazon Poly to offer new types of services that have just never been possible in the SAP space before. And so we're excited about where that's going. Finally, we want to talk about bringing the cloud closer to you. This has been a big focus for us. As initially it was, we want to be the compute platform for every workload. And we want to make sure that customers can bring those workloads. It's been a long journey over the last 14 years where we've continued to launch new instance types. We've seen many of those instance types in this presentation. But there are two sort of problems which present themselves, which make it difficult to win some workloads. And the first one of those is latency. You may have a workload today that needs very, very low latency to that compute. It could be a factory. It could be something that's controlling robotics. It could be, on the other side of the house, it could be local data. You've got some data, or a very large amount of data that you've collected maybe in your on-premise location that you just don't want to move to the cloud. And so what we started to realize was when we got to the end of doing all these different instance types, and we're by no means done, we said, well, what are we going to do for these on-prem workloads? And so what we started to hear from customers is they said, we have these workloads and we want to bring them to you. And there was actually a meeting we had early in 2018 with a telco provider. And they came on site and they spoke to us and said, we've been using AWS. All of our engineering teams are using EC2 and AWS. And we love the agility. We love the ability for our engineers to build and just deploy on machines, not have to worry about acquiring servers. It's changed our innovation. And we've got this new thing called 5G that's coming out. And we're going to be building a lot of sites all over the world. We would love to put AWS in those locations. And we said to them, well, we're not sure. Maybe we could use containers. How would we possibly make this happen? There's certainly no way we could put an AWS rack in a remote location. That was just a crazy idea. And we left the conversation. What they were really looking for was the same reliability that they were getting on AWS. They were looking for the same operational consistency. They wanted the same services and APIs. They wanted the same tools for deployment the engineers were using. And they also they loved the innovation that they were getting from AWS, and they wanted that in their on-prem location. And so about 4 weeks later, we were thinking the whole time, but about 4 weeks later, one of the engineers came up with an idea. He said, well, what happens if we take an AWS rack and put that in a remote location? What's the problem with that? And what we realized was, from a Nitro point of view, the innovation we'd done there, we spoke about security. It didn't matter whether that rack was actually within an AWS data center or somewhere else. The security of that box is so strong that we don't need the physical security that the data center provides. It still has the physical security, but the actual server itself is extremely secure. We also, with the new APIs on Nitro, we realized that the latency doesn't matter. If I put that server 300 milliseconds away from the rest of the control plane, well, I can still manage that server. It's not a problem. And so at reInvent last year, we announced the coming availability of AWS Outposts, and we're announcing the general availability of Outposts today. And so Outposts provides you with AWS designed. It literally is the same hardware that we run in our own data centers. We'll provide you with racks that you can put into your own on-premises location, whether it's a data center, a factory, wherever it might be. It's a fully managed offering. And that's been one of the things that we've seen from other providers is they will provide you with a rack that you can put in your data center, but it's not the cloud. The cloud is all about you consuming services that are fully managed. It's managed by AWS. We're managing the availability. We're managing the monitoring. All of that is managed. And so with Outposts, it is fully managed. It's a full cloud service. It's managed in the same way as if you launched an instance in one of our regions. And then it has full integration with the AWS API and console. You actually use exactly the same console and API when you're launching an instance onto Outposts. So that's what we announced. It is available as Outposts, which comes with a number of AWS services, obviously including EC2 and EBS, the two sort of foundational ones. We also have relational database service, the ECS on the container side, and EKS, including Elastic MapReduce, and with Amazon S3 coming early next year. It's going to be available in a number of countries, so anywhere within the United States, all the European countries, Norway, Switzerland, Japan, Australia, and South Korea. And if you don't see your country there at the moment, we're working very hard to make sure we can get an Outpost to where you need it. And so let us know where you'd like to see them next. That's what it looks like currently. So that's an Outpost rack, 42U industry standard rack. It arrives fully assembled with a set of casters, so we just roll it into the position that you'd like it to be. You simply plug in power and networking, and it will self-provision, provision itself to AWS, and you'll be able to see it in your AWS account as you now have an Outpost rack registered. It's centralized redundant power conversion unit and DC distribution system for higher reliability. And so you don't have to worry about power cables and things like that. It's a single cable that comes in, and it's got a bus bar at the back of the rack where every server just connects directly into that bus bar. Available in 5, 10, and 15 kVA power configurations, and with 10, 40, and 100 gigabits of networking. One of the customers we've been working with has been Philips Healthcare. And the problem that Philips had is they've built a lot of innovation, a lot of software for hospitals. And hospitals, as we continue to innovate with technology and medical technology, they're starting to generate an enormous amount of data. So whether it's your genome, your DNA, in this case, it's radiology, medical imaging, where they're doing very, very, very high-resolution images. And the challenge they have is taking those images and sending them off for analysis in AWS. Just the data transfer on their local ISP is incredibly expensive, and it takes time. And so what Philips is doing is they're actually using AWS Outposts to put their software in a hospital, and so that they can actually process all of these images and do the analysis immediately on an AWS Outpost. The great thing about that is it's using exactly the same software tools, development experience for the Philips developers that they use to deploy on AWS, they're able to deploy on Outposts. And so what do you have to do to get started on Outposts? And so the first thing you do is you log into the AWS console, and you order it. You let us know a little bit about your site. Tell us about your power. Tell us about your cooling. Tell us about whether you think the Outpost rack will fit through the door of the room that you'd like to get it into. And so a number of things we have to think about there. The installation arrives, so we will deliver the Outpost to your location, and we'll set it up for you as well. As I said, just plug in power and networking and auto provisions. And then you start launching. And so you're able to launch any instance type you'd like. When you order the Outpost, you actually tell us which instance types and machines you would like. So if you'd like some of our compute instances, our memory optimized, GPUs, if you want to do any sort of machine learning inference, you're able to do all of that and just pick the type. The rack will arrive with those instances or those physical machines in it, and you can then configure how you'd like to use those machines for instances. On the EBS side, you can also get up to 55 terabytes of EBS storage available to you on the rack, and so you'd be able to utilize that locally as well. Outpost has a local gateway, and so your on-prem network is able to communicate directly with the Outpost machine, and then it has an encrypted and dedicated channel back to AWS tied to an availability zone where we're able to manage that machine for you. And obviously build and run your applications. One of the things we need to think about is, obviously, what do we do when an Outpost server fails? So let's say you've got a 42U rack and you've got a couple of servers in there. We're monitoring those servers, and so if any one of those servers fails or has a hardware issue, we would detect in the same way we do within AWS. We're able to monitor that and notify you. And we will send you a new server, and so you'll receive an Amazon box in the mail, and there will be an Outpost server in there, single server. What you do next, and a little bit of a closer shot of the Outpost there, is there's a little clip on the right-hand side that you can see there where the servers just slide out. So you just unclip them, server will slide out, you take the new server out the box, and you slide that server in. One of the things is that server you slid out actually doesn't fit in the box we sent you. That's not a design flaw. That's one way that we get around one of the security challenges. Now, one thing you have to think about when you have a data center is how do you make sure that you never allow any data or any hard drive to leave that data center. In the case of Amazon, we have shredders in our data centers. So if you take your laptop into a data center, you will never see your laptop again. We will shred it on the way out the door. So if you walk past a certain line with a laptop, that's it. Your laptop is gone. And we literally shred every single server, every single drive, anything. Once it's in our data center, it never leaves our data center other than in metal flakes. We obviously don't want to do that for Outposts. And so what we've designed, as you can see it in the image there, is a thing called a security key. And so on the right-hand side, you can see those little devices that are sticking out in the corner. Those are actually security keys. I'll give you a closer look at one of them. That's what it looks like. And it has a chip on there that provides you with a unique private key that's used to encrypt all the data on your Outpost. And so the reason it won't fit in the box is because the security key won't fit into the box. You've got to remove the security key on the front of the Outpost. As soon as you remove the security key, all the data on that Outpost is effectively wiped cryptographically. It's the same as shredding the server, essentially, but from a cryptographic point of view. And so it's no longer usable. Nobody can get access to any data. Now, we want to go one step further. If you take a close look at that picture, you can see the little screw coming down just above the circuit board. That's a little Phillips screw. And so you take a screwdriver and you tighten that screw. And what that does is destroys the chip that holds the little security key, the private key. And so that would never, ever be usable by anybody again, and that server is effectively useless. All the data has been wiped from it. And so that's how we solve the Outpost security problem. So you would then ship back, and then it will fit in the box, and you can ship it back to us and start using your new server. The new server would be automatically provisioned, and you'll be able to launch onto it again. We've also set up a number of partners. Obviously, customers are going to start using Outposts. There's been a lot of interest, people thinking about different workloads, been a lot of questions. And so we've got a number of partners around the world that have signed up as consulting partners for Outposts, and we've been training these. So you might be some that you already work with. If you're interested in using Outposts, those are folks that you can work with anywhere in the world to help you do that. We've also got another number of technology partners. And so these are partners that are able to sort of demonstrate integration with what you do on-premise with Outposts, help you with any technological challenges, help you with some migration challenges to Outposts. And so a number of technology partners as well officially launched. You know, one of the things we're seeing, I spoke about it a little bit earlier, is the thing of latency. And more, we're building applications where latency really matters, right? We see in use cases, whether it's autonomous vehicles or whether it's factories that are being set up with a lot of robotics. Latency really matters, and so that's our global backbone today. If you want to know more about that, you can come to my networking talk tomorrow. We will dive into the networking side of things. But we started to think, well, a customer, you can get Outposts in your data center, but what happens if you just want an availability zone close to you? And one of the use cases we've been looking at, well, today we announced AWS Local Zones. An AWS Local Zone is a full availability zone at a location that's close to you. So today we announced the one in Los Angeles. So there will be an availability zone where you're able to run EC2, use majority of AWS services with very, very low latencies from the Los Angeles area because the data center is right there. That zone is actually tied back to US West 2, so tied back to our Portland region. So all of your configuration and your launching will happen in the Portland region, and the availability zone will be down in Los Angeles. And so the difference from a normal availability zone is that zone is going to have higher latencies back to the actual region, right, in the order of 10 milliseconds or so with the one that's in Los Angeles up to Portland. But for use cases in Los Angeles, it gets significantly better. The other one we've been looking at is the emergence of 5G. I spoke about latency. 5G is going to be one of the things that's really going to change latency. If you think today your 4G LTE phone is going to get you about 30 milliseconds of latency back to the cell provider, with 5G we're literally getting down to single milliseconds of latency, and that's a big change. And obviously much, much, much higher throughput. And so significantly lower latency, much higher throughput, and what we're seeing is a lot of new use cases starting to develop. So everything from IoT, more interaction from IoT devices, gaming, so really solving the problem of being able to run games on a server and then actually access those games remotely. A lot of companies investing in that. Autonomous vehicles, working with pretty much all of the autonomous vehicle companies at the moment. And one of the things about these vehicles is they collect an enormous amount of data. And often a lot of the decisions they're making may be remote in some cases from the vehicle. Terrifying to think about, but latency is incredibly important in that case. And then live media as well. And so working with sports companies that are looking to do things like put 5G on all of their cameras so that they can get away from having to drive a truck to every single NFL game, for example. So a number of different things that we're doing there that 5G is going to be enabling. And so we announced AWS Wavelength today in partnership with a number of providers. And so it's run latency-sensitive applications at the 5G edge. And so working with these providers, including the following ones, Verizon, Vodafone Business, KDDI, and SK Telecom. And so this is a global set of providers. We're literally embedding EC2 servers within their cell phone network. And so from a 5G point of view, you go from your phone to a cell tower to the local aggregation center within a city, and that's where you will find AWS. And so we're able to give you incredibly low latencies. From a developer experience point of view, you can quite simply now build an application, run it in an availability zone, but say this part of my application I would like to deploy to Chicago. This part of my application I'd like to make available in New York. Or we deploy those front ends. And so let's say you're building a game, your game users can get incredibly low latencies from their devices. And so we'll also manage the complexity of deploying an application across these various providers. So you can just deploy one application to the 5G edge, and we'll bring in the 5G from all these providers. And so it's been a whirlwind looking at performance, security, innovation. some of the things we've done there with the Nitro space. The platform depth, obviously the announcement of our Graviton 2 processor. I'm excited to see what customers are going to do with that. I encourage you all, go and build an ARM application and run it, and then start thinking about what you could migrate to Graviton 2 and what that would look like. We looked at some of the abstractions, including Savings Plan. If you haven't looked at Savings Plan, I really encourage you to go have a look at that. I think it's fundamentally changed some of the sort of consistent usage pricing models, not just in AWS, but from a cloud point of view, and then enabling enterprise workloads, and then obviously bringing the cloud closer to you in terms of outposts, wavelength, and local zones. And so there's a summary of everything we announced, both kind of pre-reInvent over the last few weeks, and then also what we've announced today in the presentation. I'll give you a second to take a photograph. It's been great talking to you. I've thoroughly enjoyed it. Thanks very much for listening. Have a good reInvent.